Welcome to the next lecture of the group theory. Today we will discuss the next definition of a group, that is cyclic group. So let's talk about cyclic group. A group G is called a cyclic group if for some element A that belongs to G, every other element of G is of the form A to the power n. So that means whenever we have a group G such that G have some element A inside, so that every other element of G can be developed or can be generated with the help of A to the power n, where n is the number, an integer number, n is some integer. So the element A is, in that case the element A will be called as the generator of the group. So if all the other elements can be generated with the help of the generator only, then this will be called as a cyclic group. Now if it is a cyclic group and all the other elements of the group are generated with the help of some element A, then A inverse will also be the generator of that particular cyclic group. There can be more than one generators in a cyclic group. Now let's see with some example. The set of integers with respect to plus, z plus is a cyclic group where the generator being 1. So now we can see that we are talking about a group z plus. That means integer, set of integers with the operation plus, and being the generator is given as 1. So we can see if we'll find 1 to the power 0, we get 1, 1 to the power 1, 1, 1 to the power 2. So now this is 1 plus 1. Please don't be confused with the 1 square. It should be equal to 1 because we are using the operator plus here. So 1 square means we need to add 1 twice. So 1 plus 1. This is 2. So 1 cube, what will be the 1 cube means that we'll have to add 1 3 times. So 1 plus 1 plus 1, this is 3. And similar way you can see that 1 to the power 4 will be a 4, 1 to the power 5 will be a 5, and all the elements we can calculate with the help of 1. So that is why we see that this given group Z and plus will be a cyclic group with 1 as a generator. And we can also see that the inverse of 1 will also be the this is minus of 1. The inverse of 1 will also be the generator. If we'll say 1 to the power minus 2, so this will be minus of 2. 1 to the power minus of 3, so this will be equal to minus of 3. In the same way, if we'll take the inverse, then we will be able to generate all the negative numbers in this. So this will be the generator. 1 will be the generator of all the elements in the Z. So now Z and with the operation plus is a cyclic group. Let's consider another example. The multiplicative group with the elements 1, omega and omega square is also a cyclic group. So the elements of the set are 1, omega and omega square, and the operation is multiplication. So this is multiplicative group. So if we'll take W, so let's consider W to the power 0 is 1, obviously. W to the power 1 is W. W square is again W. W cube is again 1. So we can see all the elements of the set can be obtained with the help of the W. Just by taking W to the power n, we can achieve all the other elements of the set. So this is also a cyclic group with the generator as W. So you can see with the help of these two examples that these are the cyclic groups. So now let's talk about another example. The group G with plus 6 is a cyclic group where G is 0, 1, 2, 3, 4 and 5, right? So now let us try to understand. Now we can see if we'll take this first operation, 1 to the power 1, this will be equal to 1. 1 square, this is 1 plus base 6, 1, this will be equal to 2. 1 cube, this will give you a 3. 1 to the power 6, this will give you a 6. right? So thus in this way you can see all the elements can be generated with the help of this generator 1. So in the same way, the 1 will be the generator of the group and all the other elements can be generated with the help of 1. Hence this will be a cyclic group. Some important properties of the cyclic group. The one property is that the every cyclic group is abelian group, so you must be aware about the abelian group. Go back to the lectures and see what we have talked about the abelian group, or try to see the definition of the abelian group. So every cyclic group is the abelian group. And the next is, if A is a generator of a cyclic group, then A inverse will also be the generator of the cyclic group. We had already talked this while discussing the definition of the cyclic group. If any element A is a generator in the cyclic group, then A inverse will also be the generator of that particular group. So this is the next property of the cyclic group. Next property, if a cyclic group is generated by an element A of order n, then A to the power m is also a generator of G if and only if the greatest common divisor of m and n is 1. That means m and n are, their HCF should be 1. That means they are prime numbers, right? M and N must be relative prime numbers. For example, it could be 3 and 5. So these are relative primes. Or let's say 5 or 11, again relative primes. So if an element A to the power 5 is a generator, then another element A to the power 11 can also be the generator of the cyclic group. So these are the properties of the cyclic group. You can go through with all other examples also. What is an infinite cyclic group? If in a cyclic group that is generated by A subject to all the powers of A are distinct, then it is called as an infinite cyclic group. So whenever all the powers of A are distinct and we are keep writing the powers A to the power 1, A to the power 2, A to the power 3 and 4 and so on, and we are keep getting the elements, then this will be known as the infinite cyclic group. So that's it for the today's lecture. In the next lecture we will talk about the permutation group. Thank you so much.